Welcome to Math 85, Chapter 2.1. The addition of property of equality is going to be the first thing we cover. That's the APE. If A equals B, then A plus C equals B plus C. That is essentially tells us that if any two expressions, A and B, are equal, we can add the same value to those two expressions and the results will be equal as well. So using the addition property of equality, in the equation y minus 7/9 equals 2/5, since we're subtracting 7/9 from the variable, in order to isolate the variable, that is to get y by itself, we do the opposite of subtracting 7/9 by adding 7/9. In order to maintain a true statement using the addition property of equality, we must add 7/9 to both sides of the equation. So here we have y minus 7/9 plus 7/9 on the left and 2/5 plus 7/9 on the right. Notice on the left, negative 7/9 and positive 7/9 cancel. That is, they add to 0. So y will be isolated on the left. Since we're adding two fractions, a common denominator is required, so the work for that is shown here. You may use a calculator to do that addition. That gives us a result of 53 over 45. Now the multiplication property of equality. If A equals B, then A times C will equal B times C, that is C not equal to 0. This essentially tells us that if any two expressions, A and B, are equal, we can multiply both sides by the same non-zero value and the results will be equal. So using that multiplication property of equality, 7/9 y equals 2/5, and that really means 7/9 times y equals 2/5. Since we're multiplying the variable by 7/9 in order to isolate the variable, that is to get y by itself, we do the opposite of multiplying by 7/9, which is dividing by 7/9. However, dividing by 7/9 is the same as multiplying by its reciprocal 9/7. So we multiply both sides by the reciprocal 9/7. Since 9/7 times 7/9 is 1, we are left with 1y on the left, which is just y, and simply multiplying the numerators and denominators on the right gives a result of 18 over 35. Using both properties, addition and multiplication properties of equality, given the equation x divided by 3 minus 14 equals 40, first use the addition property of equality to gather constant terms on one side of the equation. So, since the operation indicates a subtraction of 14, we do the opposite and add 14 to both sides of the equation. Since negative 14 and positive 14 cancel, we get x over 3 equals 54. Since x is being divided by 3, use the multiplication property of equality to do the opposite of division and multiply both sides of the equation by 3. The 3's on the left will reduce to 1, so we get the result on the right of 162. Some applications of these. Laura is 4 years older than Carol. Write an expression for Laura's age in terms of Carol's age, C. Well, since we're asked to write an expression in terms of Carol's age, C, we need to be using a C in our expression. Since Laura is older than Carol, we need to add 4 to Carol's age to get Laura's age. So Laura's age is C plus 4. Now, Jorge is 8 years older than Adelina. Write an expression for Adelina's age in terms of Jorge's age, J. Since we're asked to write an expression in terms of Jorge's age, J, we need to be using a J in our expression. Since Adelina is younger than Jorge, we will need to subtract 8 from Jorge's age to get Adelina's age. So Adelina's age is J minus 8. Anna and Maria are sisters. The sum of their ages is 45. Write an expression for Anna's age in terms of Maria's age, M. Since we're asked to write an expression in terms of Maria's age, M, we need to be using an M in our expression. In this situation, we're not comparing their ages, but we know the sum total of their ages. If we know the total of their ages, we can find one age by subtracting the other person's age from the total. So Anna's age can be expressed as the total 45 minus M, Maria's age. That is the end of lessons for 2.1.